Incredible ways we could explore the universe. You will never guess what the number one exploration is. Like and subscribe for weekly videos. In the comments below, list one topic you think should be in a top 10 video and comment if you subscribe to this channel. Humans have dreamed of traveling the stars since the early days of science fiction, and while we've managed to set humans down on the moon, launched space stations around Earth, and countless probes have touched down on the alien worlds in our solar system, we've been stuck in low Earth orbit since the end of the Apollo program. But that doesn't mean humans aren't thinking of returning to the stars. Great minds are hard at work, either trying to circumvent the speed of light and the laws of physics, or trying to find an energy source that could allow us to reach the ever-elusive cosmic speed limit. Here are 10 incredible ways we could explore the solar system and the universe. 10. Project Orion. The first thing you probably think of when you envision what it might be like to travel to the stars are ships outfitted with advanced engines like warp drives, ion engines, or something to do with navigating wormholes. But 60 years ago, Project Orion envisioned a very different method of traveling to the stars. And guess what? It involved rapidly exploding nuclear bombs behind a spacecraft. Yes, you read that correctly. Now, all jokes aside, there was some real physics behind the idea. Atomic bombs generate a lot of force, and the idea was that a spacecraft could continually ride the shock waves of these explosions until they reached a portion of the speed of light. If Freeman Dyson, one of the minds behind Project Orion, had been able to test this propulsion system for real, a ship outfitted with nuclear pulse propulsion, the name for this off-the-wall method of space travel, would drop 4 bombs a second behind the spacecraft, and the resulting shock waves would push it through space, reaching up to 11% of the speed of light. Project Orion even had mechanical tests, which used chemical bombs to provide a proof of concept. But the idea fell out of favor, not just because of the absurdity involved in the idea of dropping an untold number of nuclear bombs out the back of a spacecraft, but because of political and public concerns surrounding nuclear fallout. Still, the idea is epic, and one we're almost sad didn't see full development. 9. Electromagnetic fields. In the near future, the satellites and probes we send to the other bodies orbiting our sun may be able to sail on the magnetic fields generated by the planets in our solar system. In a proposal dating as far back as 2007 by NASA's Institute for Advanced Concepts, a spacecraft featuring a 3-kilometer-long stocking composed of a cylindrical mesh of carbon fibers and coated in a radioactive isotope could be propelled through space by Earth's magnetic field. The idea comes from the observable fact that magnetic fields exert force on electrically charged objects. A satellite could essentially charge itself up one of two ways, either by shooting out a beam of charged particles into space or by allowing a radioactive isotope to emit charged particles. Once charged up, the satellite would be gradually propelled through space by the Earth's magnetic field. Destinations with powerful magnetic fields like Jupiter and the other Jovian-class worlds are prime candidates for this theoretical technology. If the proposed technology ends up working, the probes themselves might look quite silly, featuring long filaments extending in all directions like the prongs on a hairbrush. This is mainly because a spherical design would not retain much of an electrical charge. 8. Wormholes. Wormholes, or Einstein-Rosen bridges, are a staple of science fiction. If they exist, they could act as a sort of bridge that could allow space travel to distant parts of the galaxy or universe without the need to visit the space between those places. Physicists have been playing with the mathematical possibilities of wormholes since the 50s, but despite the fact that we've now got visual confirmation that black holes exist, wormholes remain elusive. The problems with these theoretical bridges are numerous. Firstly, we haven't found any evidence that they exist. That doesn't mean they don't, but it's hard to design a spacecraft around an unproven concept. Secondly, we're not really sure how they would function, or if traveling through one would even be possible. For all we know, they could make space travel slower. 7 Plasma thrusters. The universe is full of plasma, so much plasma, and events such as magnetic reconnections and diverging diamagnetism, where a plasma generates a magnetic field in the opposite direction of the one interacting with it, often accelerate particles up to 99.99% of the speed of light. How to harness that energy in a way that's useful for space exploration is something that's on the minds of plasma scientists everywhere. New laboratory research has led to some interesting breakthroughs, and those breakthroughs are leading to the development of a new design for plasma thrusters which would utilize an expanding magnetic field called a magnetic nozzle. This plasma would be spontaneously accelerated to thrust a spacecraft through the solar system. Unfortunately, though, this proposed engine has a design flaw, in that the magnetic fields could turn back toward the spacecraft and nullify any thrust generated. Overcoming this problem would require that the magnetic field lines be stretched to infinity by the flow of plasma. A tall order. But interestingly enough, laboratory experiments have shown to have been able to maintain generation of thrust, showing that it may yet be possible. 6 Black hole drives. Reaching light speed is not impossible, but the energies required to push a craft carrying humans to even our nearest neighbor, Alpha Centauri for example, are astronomical. If a craft were to reach light speed, every ounce of it would contain 3 times more kinetic energy than the most powerful nuclear bomb on Earth. While fusion and other energy production methods attempt to solve the problem of fuel regarding weight, black holes offer an entirely different approach. In 1955, John Wheeler put out a paper suggesting that if enough energy were condensed into a single space, it would create a microscopic black hole. Fast forward to modern times and the incredible work of Stephen Hawking, whose research suggests black holes emit incredible energy which we might be able to harness. Black holes of this size, about the size of a proton, are not especially powerful, gravitationally speaking, and they evaporate rapidly. But their energy production would be 10 million times what New York City consumed in July 2013, which, believe us, is a lot. But if we were capable of containing that black hole and harnessing its energy, it would provide more than enough fuel for humans to reach 99.999% the speed of light. The trouble would be ensuring the black hole didn't just evaporate, among many, many other engineering challenges. 5 Real warp drives. Since the dawn of science fiction, writers, readers, moviegoers, and eager scientists looking to the stars have dreamed of a time when we might be able to break past the speed of light. Star Trek and other science fiction properties envisioned technology that could essentially warp space-time around a ship, compressing it in front of the ship and expanding it behind it, allowing space itself to move around the object, rather than the object moving to and from those locations. For the most part, this idea has remained in the realm of science fiction, or even science fantasy, depending on who you talk to, but as far back as 1994, scientists were beginning to see the potential for a real form of warp speed travel which could take us to the farthest reaches of our galaxy and beyond. One hurdle to get through is that the proposed warp drives would require negative matter, not antimatter, to make them viable. Physics may forbid particles and anything with mass from traveling beyond the speed of light, but negative mass is possible. And amazingly, this was proven to be true. Physicists were able to produce a fluid with negative mass in the lab. Essentially, what this means, is that the fluid would move in the opposite direction when enacted on by a force that would push an ordinary fluid away. It might still be wishful thinking to suggest that warp drives are that much closer to being achieved, but the discovery does at least seem to suggest it's possible. For breakthrough Starshot, one major hurdle for interstellar travel is weight, and most of the weight in a spacecraft would be devoted to fuel. Traditional terrestrial rockets like the Saturn V rockets that got us to the moon burned 20 tons of fuel per second as it broke free of Earth's gravity. This is wildly inefficient. But a company called Breakthrough Initiatives suggests that the problem could be solved by unmanned probes. Who said humans had to be present in a spacecraft to explore the galaxy anyway? Breakthrough Starshot is a plan to launch probes weighing less than 1 gram and blast them through interstellar space at 20% the speed of light to our nearest stellar neighbor, Alpha Centauri, which is 4.4 light-years away. The team behind Breakthrough Starshot has suggested that, if successful, its probes could reach Alpha Centauri in just 20 years. For a bit of perspective, the New Horizons probe which photographed Pluto's heart-shaped surface took 9 years and 5 months. Of the hurdles faced by the team are developing a reliable means of slowing their probe down, and a rechargeable battery that could power all of the microprobe's internal systems for the entirety of the journey. Still, the project is intriguing, because it's theoretically achievable with our current technological limitations. 3 Fusion propulsion. It's a common joke that fusion power reactors are the future and they always will be, but breakthroughs in the lab are starting to yield promise, suggesting that a spacecraft powered by a fusion drive might see its launch by the year 2028. The proposed design boasts a travel time to Saturn and Pluto in just 2 and 5 years, respectively. The latter is almost half the time it took the New Horizons probe to reach Pluto. Researchers behind the development of the Princeton Plasma Physics Laboratory's PFRC-2 drive say that their research could be the key to unlocking feasible travel throughout our solar system. The engine would be powered by helium-3 and deuterium and would combine the principles behind electric propulsion systems and the immense thrust generated by chemical rockets, effectively giving the best of both flight systems. The size of the reactor would be small, especially when compared to prototype fusion reactors currently being tested, and would employ a unique plasma heating system, which would theoretically yield positive gain for energy, something which has never been achieved in a fusion experiment. Still, even if the team behind the fusion engine can get it working, the speeds we're talking about wouldn't allow us to explore the galaxy, and this technology would probably only be used in inter-solar system exploration. 2 Bussard Ramjet. First imagined by physicist Robert W. Bussard in 1960, a Bussard Ramjet would utilize magnetic fields to scoop up hydrogen fuel instead of carrying it aboard a spacecraft for a sustained fusion reaction, like the previous century would do, and thus, this would theoretically allow a spacecraft unlimited fuel so long as the ramjet could continue to gather more fuel along a magnetic field, cutting down the time it would take to travel to other stars to years, rather than centuries. Don't get too excited by this possibility, though, as quite a few problems have emerged from researching the possibility of developing ramjets. First is that a Bussard Ramjet would have to already be traveling at extremely high speeds to collect fuel with its ram scoop, thus requiring any potential ships like this to carry an initial payload of fuel. Second, maintaining constant thrust might result in the engine overheating, and creates some unique challenges for electromagnetic engineers. The third, and worst problem, is that the ramjet's unique act of scooping up hydrogen fuel might create enough drag to negate any acceleration gained. Still, scientists suggest that even if a Bussard Ramjet is never realized, the results from that research will not be wasted and could lead to amazing technologies. 1 Photon rockets. As explained in earlier entries, rocket fuel tends to be extremely inefficient, and the immense weight of all the fuel required to maintain thrust on any given journey through space significantly limits the speeds which can be reached by conventional spacecraft. Planck photon rockets could change that, and engineers are boasting speeds equal to 99.999% the speed of light. The rockets would be propelled by directional thrust from luminous electromagnetic radiation. If the particles produced turn into a hypothetical Planck mass particle, theorized to be microscopic black holes by the late Stephen Hawking, then relativistic speeds would be possible. If the Norwegian professor behind a research paper outlining the potential for photon rockets, Espen Garde Haug, is right, then the technology could reduce travel time to Mars to mere minutes, and the professor even claims that they could be powered by anything so long as the fuel has a 100% conversion to light energy. While laboratory experiments do show that the concept of driving an object forward with the use of photons is possible, we're still a long way off from making photon rockets that could send people into the depths of space. Even our largest particle colliders aren't nearly big enough to test these ideas. Not yet, at least.